We're looking at the sum of a geometric progression. Now, remember, when we talk about the geometric progression, we have A being the first term and R being the common ratio. So, let us say we have a geometric progression. The sum is equal to, the first term is A plus the second term, you multiply A by the common ratio, plus the third term, you have the first term, AR, multiplied by the common ratio R. So what you get is AR squared plus the fourth term is going to be the third term times R again. You remember that? AR squared times R is going to be AR cubed plus and so on. Plus. Now, let's go to the last term. It is AR to the n minus 1 if you have n terms. Alright? Now, suppose we multiply all of this by R. We say R times S is equal to, multiply A by R, we get AR plus, this will be AR squared plus AR cubed plus AR to the fourth, and so on and so forth. Alright, let's not use AR to the fourth since we don't have it up there. We go on plus the last term. Remember now, we had AR to the n minus 1 multiplied by R, which is R to the 1. But when we multiply R to the n minus 1 times R to the 1, we add the powers. Remember the laws of indices is plus 1. Now, n minus 1 plus 1 is equal to n, because negative 1 plus itself, and that is gone. Alright? So what we have is AR to the n. Now, we had a term before it. What was it? Well, that term before it would have been AR. How do you find the term before? You're going to divide by R. So it's AR to the n divided by R, which is R to the 1. Remember, laws of indices, when you have R to the n divided by R to the 1, is the same as R to the n minus 1. So what you have before is AR to the n minus 1. Alright? Now, the thing is, we want to subtract these. Let's subtract them, but before we subtract them, let's take all of these and shift them. So you have A lined up with A, R lined up with R, and so on. So I put AR below AR, AR squared below AR squared, AR cubed below AR cubed, and so on. AR to the n minus 1 below AR to the n minus 1. Alright. Now, we have the R S equal. Let's shift it back here. Now, what we would have before AR would be 0. Let's hold the place here with 0. And after AR to the n minus 1 up here, let's put 0. Now, let's subtract them. S, what we're going to have is S minus RS is going to be S minus RS equals. This is going to be A minus 0 So it's A plus AR minus AR. That's 0. We don't have to write it. AR squared minus AR squared. Oh, yeah, that's 0. This AR cubed minus AR cubed is 0. And so on and so forth. AR 4 to the 4 minus AR to the 4 is 0. And we come to AR to the n minus 1 minus AR to the n minus 1. That's gone as well. That's 0. 0 minus AR to the n now. We have negative AR to the n. Alright. So this now would be S, open bracket. Let's factorize it. 1 minus R. Okay. Equals. This is A minus AR to the n. So S times 1 minus R equals. We have A 1 minus R to the n. Alright. So what is the sum? We divide by 1 minus R. So it's A 1 minus R to the n divided by 1 minus R. So there we have the sum of the geometric progression, the formula for getting the sum. Now, suppose we have a very large number of terms to add. We want to find the sum to infinity. What would it be? It would be interesting. Now, here, we will be able to find the sum to infinity if the common ratio is less than 1 or is between -1 and 1. Let's look at the sum to infinity in our next video.